This is the video for Mod 2 Lesson 1, which is solving exponential equations. Okay. In this first lesson, we're going to be looking at solving exponential equations. Exponential equations are in the form of b to the x equals y. And the steps we're going to use throughout this mod are listed below. We're not going to use these steps necessarily today. In today's video, we're going to more use the one-to-one property, but kind of the theme we're going to end up having is we're going to be isolating our base. And eventually in the later videos, we're going to be taking logs and solving for x. So these steps we're actually going to use in a later video. But I just wanted you to see them just so when we come back to, if you come back to this page, you kind of remember some of the steps for solving. One thing you're going to have to know for this mod are some of your exponent rules, which we've practiced over the past couple classes. And they're basically going to come up when we end up solving. So our first one is illustrating our product rule here. So if we're doing 5 to the 3rd times 5 to the 7th, remember if you're multiplying like bases, that's the same as adding those exponents, and that's going to give us 5 to the 10th. If I'm dividing, that's going to be the same as subtracting. So if I have 5 to the 3rd over 5 to the 7, that's going to be the same as 5 to the 3 minus 7, or 5 to the negative 4th. And if I have a negative exponent, that's the same as taking the reciprocal. And this is one of a couple different ways you could do that problem. Another property we see in our third problem is the product or the power to a power. So I have 5 to the 3rd raised to the 7th. So that's the same as doing 5 to the 3 times 7, or 5 to the 21. If we have a negative exponent, which we kind of saw on the previous problem, remember that's the same as just taking the reciprocal and making it a positive exponent. And our last one, if I have any base raised to a 0 is going to be a 1, right? So some of these properties are going to come up in this module. So remember, if you're multiplying like bases, you're going to add the exponents. If we're dividing, we're subtracting. And then power to a power, we're multiplying. For example 1, we're using, and this whole lesson is looking at solving using the one-to-one property, which we also did a little bit in mod 1. So the idea is if we have two like bases and we have an equation where they're equal to each other, I could actually just simply set the exponents equal to each other, right? So this idea isn't really too new, but we're going to end up using properties of bases and exponents quite a bit in this module. So if I want to solve this equation, and this is an exponential equation because the variable is in the exponent, this first one's pretty straightforward. So if I have two like bases and the bases are the same, I can just simply take the exponents and set them equal to each other. So we end up getting x plus 1 equals 9. And when we go ahead and solve it, we'll get our value of x to be 8. Same idea if I was to go ahead and, for number 2, we're going to do the same thing, but one thing you're going to notice is there's multiple bases on one side. So we're going to actually use our exponent properties that we just did. So if I was to rewrite this problem, and if I'm multiplying these like bases, I'm actually going to go ahead and add those exponents together. So k plus 2, which is going to give me 3 to the 2k plus 2. And then I have this as 3 to the 5k minus 1. Now that we have both sides have the same exact base, we can go ahead and take those exponents and just set them equal to each other. So we're going to go ahead and do that. We have 2k plus 2 equals 5k minus 1. And then just simply go ahead and solve. So now this is just a linear equation. And we should actually end up with our k value being equal to 1. In example 2, we're looking at, again, using the one-to-one property, but where they don't have a common base given to us. So we have to rewrite it using a common base. So we see for the first one, I have 6 to the 2x minus 10. And then we have 36. We're going to try to write 36 using base 6. So 36 is actually 6 squared. And now we have our two bases being exactly the same. And we're going to go ahead and set our exponents now equal to each other. And so when we go ahead and solve, that's going to give us our answer of x equals 6. And finally, for number 2, same idea. If we have 2 to the p minus 7, I'm going to try to rewrite 8 as base 2. So 8 is actually 2 to the third. And now you can see our bases are the same, so we're going to set them equal. And we're going to solve. And so our answer for that would be p equals 10. In these last two examples, this is where we have to rewrite a common base and maybe have to do a little more simplifying. So this first one, we have 5 to the 3x plus 1. For the second part of that equation, 25 can be written as 5 squared. So 5 to the second. And then in my parentheses, I'm going to write x minus 2. And now we have the same base on both sides. And we're going to again go ahead and set these exponents equal to each other. So we have 3x plus 1 equals 2 times x minus 2. And now we're just going to go ahead and distribute and solve. So if I distribute my 2, I get 2x minus 4. And then I'm going to solve for x. And so our final answer is negative 5. For our last question, if we look at the left-hand side, we have like bases. So I'm going to go ahead and add those together. So 2x plus 4 plus 3x. And so on the left-hand side, we're going to get 5x plus 4. On the right side, I actually have 1 over 81. So we know 9 squared is 81. And if it's a fraction, I'm going to end up having to use a negative. So 1 over 81 is actually the same as 9 to the negative 2. And we have our like bases, so we're going to go ahead and set them equal. And then go ahead and solve. And so our answer would be negative 6 over 5. Or you could make that into a decimal. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.